My name is Natasha Polishuk. I'm here with my colleague Mason Lentz. We're going to be talking about Fuzzy Wuzzy, which is a pretty simple and easy to use package to do something pretty complicated and very interesting, which is record linkage. We both work at Cresco Labs, which is headquartered here in Chicago. It's a cannabis company, so our main example will be related to cannabis. However, we do not speak for Cresco Labs. We're just here to share this cool package. Say hi, Mason.
Hey, everybody. I don't know if I've been on any of these before, but happy to be a guest and appreciate everybody having me.
Okay, so I'm going to get started with this presentation. I'm going to drop you for now, Mason. All right, so what we have is a problem that comes up pretty frequently if you work as a data engineer, data analyst, data hygienist. Basically, you have data from different sources. So for example, we have our state compliance system that's used in a few states for cannabis specifically, but you might have any kind of database, CRM, Salesforce, email subscribers. And the problem is, if the names were exactly the same, it would be very easy to match them across different data sources. Unfortunately, people will sometimes put one name in one database, for example, this Jonathan J. Prufrock, and then they go to make a purchase, which is a different data set, and it comes in as Jonathan Prufrock. So just looking at this list, we can be pretty certain that Jonathan J. Prufrock probably is Jonathan Prufrock. It's kind of an unusual name, but a computer has no real good way of telling that just as a straightforward match. So you can't just do an equal sign. So we also have things like misspellings. For example, Mike Raynard is very clearly spelled incorrectly here. There is probably a typo. And then sometimes people will use nicknames. So Don Kennard versus Donnie Kennard, right? Will and William, things like that, you'll see a lot. And you want to match these folks up because sometimes you want to give credit to your marketing campaign. If you work in digital marketing, you might want to better target people, or you just might want to give them better service. So recommend products that you think they'll like next time based on their past purchases. There is a solution, and it's great if you have data from, maybe you work at an agency where you're serving multiple clients and you need to figure out if they have any overlap. Maybe you're dealing with dozens of data sources. This will definitely be true if you're working with social media, like people who are giving you likes on Instagram. Are they also engaging with you on TikTok? Do you have millions of records, or tens of millions, maybe even more, where you're starting to get into big data where it's just physically impossible for even an intern to look through all of the records? How can you account for spelling errors that we all know happen all the time because data is entered by humans? Or maybe you would like to compare information from different fields. So you're not just only interested in the person's first name and last name, but you'd like to get even better matching by also adding in information like phone, email, name, and address so that you can be actually even more certain, right? So how do we compare people who have their first name, last name, and an email, and then they have first name, last name, and a phone number? Is there a good way to match them up? And it's not limited to really just people. It could be companies, products, sources of text. Really, this has applications in a lot of different industries. So it is called record linkage very formally. This term is well defined by the Python record linkage toolkit. It's basically a procedure to bring together information from two or more records if we think that they are probably the same entity, so the same person, company, product. It's also used for multiple data sources or to remove duplicates in a single data source. So it's kind of annoying when you have a large list and there's a lot of redundancies. So this is one way to kind of join up duplicates. If you are interested in this field, I do recommend the Python record linkage toolkit. It does give you a lot of extensibility and flexibility. Today, though, we're going to talk about a very easy solution. So if you have a project due tomorrow and you need a solution, you can just dive right into Fuzzy Wuzzy. And Fuzzy Wuzzy is a great package. It's very well documented. It's 10 years old, so the bugs have been worked out. And SeatGeek, who is a vendor of events and sports tickets, so they both sell and resell them. They developed this, and they were kind enough to open source it so that anybody can use it. At the bottom here, I do have a link to their original blog post where they explained this very well. I'm going to take a couple of their examples and talk about string similarity and partial string similarity. So when you're really just trying to see if letters are pretty similar, that there might just be a little bit of a typo or a little bit of shorthand. And then Mason will take on this concept of token sorting and sets that is a little bit more advanced. Okay, so the simplest thing you could do is just figure out a ratio, right? And so the ratio is basically a score of how similar two pieces of string are. We know that we know that New York Mets is a real team, and we believe that if somebody wrote New York Meats, it is probably a typo, that they were probably referring to this real team, New York Mets. And so it's probably a good thing that if we throw them into this fuzz ratio function, that we get a score of 96 out of 100. We would expect that because we'd probably agree that these two pieces of text are very similar. So if you really wanted to just kind of get started with this right away, you have a list of email subscribers, say, and you have a list of purchasers. Here's some very simple Python, just a nested loop where you compare each subscriber to each purchaser, and then you get back a list of the similarity ratio for each one. And so at that point, you could turn it into a data frame and sort it by similarity descending, maybe even add in a cutoff at that point. And this actually works really great in a few straightforward cases. So if two strings are in the same order and they're just off by a few typos, that's a great use case. But SeatGeek soon found that they had other cases. So they had other situations where, for example, somebody would type in Yankees. There's not another Major League Baseball team called Yankees. So they probably meant the New York Yankees, but it doesn't give us a very good score. 60 out of 100, I don't know that that would make the cutoff that they probably have. They might have their cutoff set to 80 or 90. And then they also noticed that they had scenarios that really weren't as accurate as they would want. So New York Mets and New York Yankees had a pretty high score of 75, and that's just because of the New York text. But just because they're both from New York doesn't mean that they share the same fans. So you probably would want to adjust the way that you calculate your score at that point. So the second option that we have is the partial ratio. And so if it's a way of comparing the smaller string and seeing if the string is found as is or very close inside the larger string. And the great example is Yankees is inside of New York Yankees as is, so it gets a score of 100. In that case, it's a really great application, right? New York Mets, New York Yankees, that actually has been downgraded. And you can see that in some cases, you might actually want to apply both types of ratios, and one will work better than the other. That's why there are options for you. So I'm going to turn it over to Mason to talk about a code example in a real-world solution. So just one moment, please.
Should be good. All right, so we're going to be going through a real world solution next. Before we do that, let's just go through the additional functions from Fuzzy Wuzzy we're going to use. So just to preface kind of the example we're giving, basically at our at our company, and I'm sure at a lot of different companies, there's a lot of problems between a master SKU list at your own company, right? And a third party provider that you're using for internal transfers, maybe they're, you know, a supplier portal, right? They might just have slightly different product names and or completely reordered names, additional context to them. So we ran into the issue of when it's a time sensitive scenario, it's hard to match these one to one and it takes time for people to go through this list and match. So before we got a good system to assign them, right, before they even were coming in, we found that Fuzzy Wuzzy had a function called token set ratio, which actually created the closest match for our products between systems. The solution ended up being about 95% accurate at any given time in its life cycle, which for a process that is time sensitive and would take a decent amount of hands on deck to get everything, one to one matched, right? When you just get an incoming order, for somebody to be able to read that incoming order with 95% accuracy, that's what the inventory is coming in. It is useful for creating orders, right? Or anytime you need to know an inventory level, having about a 95% accuracy when it is time sensitive is you know something that's workable in a shorter term. So this is a great option for those kind of scenarios, and or even when you have only a small batch of products that aren't joined yet, right? And you are already making case win guesses. This is a good way to overwrite those kind of options. So token set ratio. This function basically breaks out a product name by each space in the text and individually checks those chunks of text anywhere in the product names it's looking against. Within the code, how I use it is I utilize the highest scoring pair that it found using the token set ratio, and I pull that out and assign that as the match to the third party system, pushing them all and then appending them, right? So we'll see the actual example in the live demo, but before that, let's see what token sort ratio is all about. This is going to be one of the other functions that I will be showing in the demo. I'm going to be showing what the scores come out for each of the different scenarios. So we tested this methodology because product names were commonly very similar but missorted. So our internal example is this Bedford Grow Highwayman Crumble 1 gram. That was from our internal system, right? The external system, it was Highwayman Crumble 1G Bedford Grow, right? It's the same word. It's not going to match at all, right, in a normal system, but we're using the token sort ratio. It'll sort them, right? Each of the sub contexts of the string and match them and give us 100%. So you can see the other example below using my name is Ali, and I'll use my name. Because it contains each of these subparts of the actual string, these will be 100% match. Lastly, I want to cover again the token set ratio. The primary big difference between sort ratio and set ratio is that set ratio will get rid of any part of the string that might not connect to one of the master list items. So basically, it will look for the highest part joined to anything that's out there. So really, in this example, this might be extra, product information. For example, in some of these, it'll say, case pack of 96. Our internal list isn't going to say case pack of 96. It's going to ignore that in that case if it can find all of the other product connecting information in the master list and give it still 100%, not killing its weight because of the pack of 96 in there. So that was the reason we finalized going with the token set ratio, because of the extra fluff that this data source was sending us. So let's take a look at this as a demo. So I will pull up the code. Hopefully everybody can see this okay. So just to start, how do you install Fuzzy Wuzzy, right? You open a terminal, you do your pip install fuzzy wuzzy, get it installed. You do the same process with pandas if you haven't done that already. It's one of the original packages. And then OS comes with Python, so you won't have to worry about that. So here we just basically set the user path for where you put the associated intake files for this example. I'll open those up right now before I get to the portion of the code where I pull it in, just so you can get a feel for what we're looking at. What I did is I took, 5 sample raw names that I've seen in the past, right? You can see this case of 96, not great. It says 5-pack. These are very interesting names, right? Not something you'd find in a master list, right? Over here, we have the more internal master list comparisons. I grabbed 3 examples that were similar and one that was actually the right one for each of these. Just to give an example, the joins matched on the right one in all cases, but it gives a good example of how the scores work. So in these portions, right, I'll pull in the incoming transfers product. This would be a third party that, this is the items that you don't really know how they assign to your master list, right? So these come in as incoming data, master list, pulling them in as a CSV to a pandas data frame. Basically what I'm doing here is I'm doing a little bit of pre-cleaning. This is more of like a dictionary clean, just knowing that whenever I've seen this in our master list in this other source, it's, shows up as this, just so it doesn't get too counted against it. I make things lowercase to get rid of any issues with that. Dashes, spaces. And then what I'll be doing is each of the methods will be, the first one will be ratio. Here basically is the process for fuzzy wuzzy where you take your incoming data. So this is that list of 5. I'm taking the first one in that list and I'm comparing it to the full list in the master list, doing a ratio and limiting the grab for the join that I found, right, to 1. I'm going to be repeating this process with the token sort ratio and set ratio, and then putting them all together into one file, pushing that to a CSV. I will run this in an interactive window just so you can get a feel for how it might look in your variables. We can take a look at what the DF that got exported. All right, so that's how it's going to look in Python, but let's pull it up in the Excel. I made it a little bit cleaner here so everybody can get a feel for what this does. So the first one we're going to be looking at is this ratio. So this is the quote unquote, SKU ID for our master list to assign. This is the master SKU name to assign. This is the original name, right? And each of these did get, it looks like, except for this one, right? This doesn't even look like it gave it the right SKU name, right? It chose the East Coast Sour Diesel. This is wedding cake, right? They all have pretty low scores. So this is pretty low confidence, even on the ones that did get a match. So ratio is kind of our, lowest common denominator, right? It's really good in certain cases, but when it comes to these larger strings, it kind of falls off the boat, especially when there are similar variations of, the same kind of characters. So then we get to the sort ratio. This is where we get to kind of the, better functions, right? This is the token sort ratio. Does look like for pretty much all of these, right? It's like, okay, we got the right matches. This looks pretty good. Hard part is these scores are still kind of low, right? This is due to these, case of 96, right? Case of 48. These one-off characters that don't really mean anything in our master list, right? But are in there basically reducing the score that you're going to get. Until we can get to set ratio, which does get rid of the extra, stuff in the original name that you're looking up against, right? You can see these scores are much higher, and it did get the right joins for each of them. I'll be sharing these examples. Oh, your mic's
Thank you. Thank you so much. So Mason and I did just give this presentation during the day to our colleagues, and I just wanted everyone to know that even though this is kind of a simpler example, this already is in use, and we have ideas to extend it more at Cresco. So it's a very valuable tool. But I want to give you just a little more info about record linkage, because you might get into a situation eventually where it's not enough, all that Fuzzy Wuzzy can do. You might need more control about how the data is pre-cleaned. So Mason mentioned that the token sort ratio will lowercase the data and it will sort it, right? So you might need to, I'd remove punctuation, but you might need to convert all numbers to text, or like take out all numbers, or anything that is more industry specific for you. There are packages that they can get very sophisticated. Again, that record linkage toolkit we talked about earlier is a great tool to kind of be more flexible. It will also allow you to try different distance measures, which I want to talk about more in just a moment. You also might combine all of this with human reviews. So I did work at a place where we had scoring and we had a score threshold, but then, you know, whenever you just had some free time, there was an interface where you would kind of rate matches that were on the cusp. So anything, let's say, between a score of 70 to 80 would actually just be sent to human review, and we'd say, yes, this is definitely the same company, or this is definitely not the same company. Because at this point, humans, I think, are still more better at this kind of work, but algorithms are getting more complex all the time. So just to talk about a couple different distance measures very simply and quickly. One of the simplest things is just to try to find the longest common substring, so the longest piece of text that is repeated. And there's a great example in this names of Megan and Marvin. The letters M-A-N are repeated in both names. And then we can get a longest common substring distance based on letters that they don't share. Then Levenshtein distance, this is one of the most common text distance measures. It is basically how different, how likely a typo is kind of. It's a text edit distance. It can also be explained in this way when you say how many insertions, deletions, or substitutions would it take to arrive at this new word. So again, same example, Megan to Marvin, and there are 4 steps. So the reason I really want to highlight Levenshtein distance is because it's one of the most popular. 2, it's exactly what Fuzzy Wuzzy uses under the hood. So if you're wondering about that, you can kind of look it up more either on this link here. I'll share the slides later, or there's a great Wikipedia entry. It was a mathematician in the 60s who came up with this. And then it sounds like there was a guy named Demeraux, or another mathematician, let's say, Demeraux Levenshtein, who just said, hey, you know, sometimes things are just transposed and we shouldn't count it in the same way. So it allows for transpositions, and you can have words that are super similar that should actually be scored pretty highly. So like, instead of counting this as 2 steps where L is swapped with E, you count this as 1 step because they're just swapped. Okay, and the final one I just want to mention is Jacquard distance, which is kind of a way to compare like shared letter sets. Again, what Mason was talking about was tokens, so words were considered tokens. In Jacquard distance, you might have like 3 letter sets, and those are compared. So not too far of a departure. And again, there are dozens more. If you get interested in it, it's a very cool field. There's a couple other resources, and you can even look up how the Census Bureau is using it. It's got like wide range of applications. And I noticed in the comments that another person said that they also use Fuzzy Wuzzy already to match business names and addresses at their job. So we'd love to hear from anyone if you have questions. I also want to put in a request that if anybody would like to do a presentation for the next quarterly data special interest group that we would love to have you. I'm looking for speakers right now. I think we can be flexible, whatever timing works for you. Just let me know. Would love to talk more. Okay. And also a big thank you again to Mason, because it's really nice that you were able to take time between working full time and also getting this presentation together as a bonus. So I appreciate that. Okay. I actually don't really see any questions. If you're not already on the ChiPy Slack, join ChiPy Slack. I'm on there. It's just my name. So feel free to chat me there. Oh, okay, excellent. Michael, it does not stem the words. I'm gonna throw Mason on to confirm, but I'm almost certain that like token sort and token set does not stem the words. Do you know, Mason?
Stem the words as in?
Yeah, so if you have like running and ran, so those are all really variations on the word run. And so a really intelligent tool would consider that to be the same word.
Yeah, you can do that, but I think that's more like plugging in a custom dictionary, which all of these things support. It just takes a little finagling.
Oh, and thank you, Pablo. I appreciate the thank you. All right. Okay, I'm gonna end the broadcast if there's no more questions. I really appreciate you all attending, and it was great to see you all.
Thanks for having me.